much for having us here. It's a real honor to come and speak, and it's very exciting. Headsprout was a act of love as much as it was a business endeavor. We really wanted to do something that would change. I worked in Chicago, big city in Illinois. You probably all heard of Chicago, and there's a lot of poverty, a lot of kids not being getting the education they need. And we worked in the schools, and we developed programs that reached 17,000 kids. And this is teacher training and application of behavioral and generative instruction procedures in the schools. But what we found was we could not reach enough. That given the teacher turnover, in other words, they would come and they would go, you were constantly retraining, we found that all we could do was to keep things at the level we had it and not be able to grow it really. And there were 500,000 children in the school system, and all we could reach was 17,000, which sounds like a big program, reaching 17,000 children. But when you realize the millions of children and the hundreds of thousands of Chicago alone, we couldn't do it. So that's what actually sparked Headsprout, wanting to do something on a larger scale. When we started, to put things in perspective, we began this company in 1999. The first commercial web browser was introduced in 1995, only 4 years earlier. People thought we were crazy, that no one would ever want to use the internet to teach, that this was before anyone had anything other than dial-up modems. And if everybody is, who is my age and maybe a little bit younger, I've heard they'd scream at you when you'd log on and make all kinds of noise, and it'd be 300 baud, but then we got up to 1400, and that's like, if you had that speed right now, you would all leave and be very frustrated and very angry right now. So, but this is the context in which we had the idea that we could do this. We could reach people over the internet because we knew that the internet of today was not going to be the internet of tomorrow. And so we designed a highly adaptive program. We brought in highly skilled software engineers. And our vice president of software engineering, his next job after Headsprout, and we'd sold the company, and I'll tell you a little bit about that, was the director of machine learning for Amazon. So this was a really advanced set of technologies that we developed that was all informed through behavior analysis. And we had the task of how do you teach a child to read that you cannot hear and you cannot see? And when you think about it that way, you're teaching someone to read who you cannot hear or see. And that was our task. And we began reasoning from basic principles. We didn't go out and look for analogies. Well, who's done this before and who's done that before and where do we see this? I made it how can you put it this way? I refused to look at the reading literature because I figured they wouldn't. I wanted to do this from an idea of applying just the principles of the behavior analysis to solving this problem. And that if the reading literature had done such a good job, everybody would be reading. So we didn't do it. But I don't want to spend too much time on this, but I just wanted to give you a background, and that we stand at a similar place where we stood there with the internet, with the 300 baud, and everything's kind of moving slowly, and everything was on disk, and people were telling us, oh, you got to put it on disk. And we said no. Up to this point, by the way, that program has taught over 3 million children how to read worldwide. Over 3 million. And it's still going strong today. It's now sold by a company called Learning A to Z, whose director of instructional design was a former Headsprout instructional designer, and whose vice president of strategic planning is a former Headsprout person. So Headsprout infiltrated that company that acquired it, and the program's still going, and they're still building more. We have one of the key Headsprout designers, Dr. Melinda Soda, with us today, who actually is a patent holder as well on the reading comprehension program and the music program. And so it was very exciting to do this. And today I want to talk about something similar event, and that is the advent of artificial intelligence. And we hear a lot about it in the newspapers, and the realm, and it's in its infanthood kind of thing. And if I were a younger, well, you know, I actually am doing it. So even though I'm not that young anymore, but if I had a little more energy, maybe, well, I got plenty of energy. I don't know. I've got to think of some excuse. This is the area that is emerging, is the artificial intelligence big data area. This is where we're standing on the cusp of a major generative explosion. And I'm going to talk about that today and the opportunities and the challenges for behavior analysts, because there are technologies being developed that can actually bring our field to many, many, many people at scale, and sometimes without us. So this is what we have to look at. So we're going to look at what this all means for the future of behavior analysis, as well as how behavior analysis contribute to that future. The first thing I want to talk about is big data. I don't know if big data is in Greece is as talked about and as much as it is in the United States, but big data and analytics is becoming one of the driving forces in business and education in the United States. What they mean by big data is that the algorithms that are being developed today, an ability to analyze data at massive scales, allow people to look for correlations among data that will make predictions that people find useful. And so they take data from all sources that are basically unrelated conceptually. And by that I mean that they will do things such as, this is an actual example, this is a company who made facial cream. And they were targeting the facial cream, and they wanted to know who was our user. Can we predict and tell exactly who our user is so that we can target our advertising to that user? So they went and looked at all the data that they could get. And what kind of data did they take? They take data such as all the demographics, meaning the age, the income, where they live, what area of the cities they live in, whether they live in the city or the suburbs, what temperature is at most times during the year, do they own pets, how many traffic tickets are given in front of the front yard, all these types of things. Data sources from any place. They don't care. The more data, the better. Then they begin running these algorithms. And the algorithms look for correlations that will predict. And what it came out is, in this particular case, it's a woman in her 40s who lives in the suburbs and who owns a dog. Now, they're not trying to say anything predictive about this or causal. They're saying predictive, but not causal, is what I meant to say. And the essence is, if you take away the dog, that wasn't a customer. If you move the person with the dog, but they live in the city, not a customer. If the person's in their 50s or 30s, they're not so much a customer. They targeted this person and their sales doubled. All right? Here's another one. Hospitals are looking at big data analytics. And they're looking at, for example, who is likely to return to the hospital after being discharged within 30 days? Who's the most likely person? Because those are the people that you can target with support and services and so on, so you don't have to keep your costs down. Well, they found that it was women, the mid-60s plus, discharged to live with a working child and working spouse who came from a lower income category, had an 80% likelihood of returning to the hospital within 30 days after discharge, regardless of diagnosis. Make it so that it's only one spouse working, don't return. A little higher income or even lower income. If they're on welfare without making any income, they don't return. These are the characteristics. And when you find this, and they did this by this, no one came up with this. Say, hey, what do you think it could be this? There's no thought goes into this to prepare this data. These algorithms just work on the data alone. All right? Here is actually a picture of Garfield High School in Seattle, Washington. My two sons graduated from this high school. And they wanted to know if they could predict who's going to drop out of high school. Who's going to succeed? Who's going to drop out? Who is the most at risk for dropping out? Attendance in the first 20 days of freshman year predicts a graduation rate 4 years later. That's what the big data analytics found. So you could simply look at the attendance rate data, and if you had a certain attendance pattern in your first 20 days of school in your freshman year, they knew who was going to drop out. This is what big data analytics are doing for us. Taking characteristics of individuals and their community and their environment and analyze them to find correlations that allow prediction. How is this accomplished? How do they do it? Well, they have a series of what's called data mining algorithms. And these data mining algorithms look for different classifications and ways of putting data together and so on. And if you look at this, I don't know if you can copy this down, there's 10 of the most frequently used data mining algorithms are at this site. All right? So, so if you're interested in seeing what those algorithms look like, and there's some pretty good explanations of what they are in there, by the way. And this is called, and so this is how they put it together. But the one that excites me the most, yeah, taking a picture of it is probably the best idea. That's a telephoto lens. I'll get it right up there. That's good. I like that. She comes prepared. All right? Everybody got it? Who wants it? You can see me after, too. I'll send it to you. There's a thing called genetic algorithms. And this is the one that is actually pretty amazing. And this site, too, gives you a little tutorial on genetic algorithms. What this is that there are no algorithms that correlate the data that are used to analyze and correlate the data. Instead, it's an algorithms that go through and make predictions based on the aggregate of the data, and then they see how the prediction relates to what it is you want to predict. And the algorithm then produces offspring with variability in the algorithm. And they run it again and see how close it is to the prediction. Then they have more offspring, and they crossbreed it. And it's a genetic algorithm based on selection where the algorithm writes itself. And it is actually generating, and the hospital, about the patient, the women there was from the Kaiser system in Pennsylvania, that example came from, they use genetic algorithms. In essence, the algorithms evolve over time to predict, and the programmers have no idea what's actually being used to make the prediction. They don't know what the ultimate algorithm is. It's all part of a neural network that evolves through this selection process. And so basically, they're using principles of selection in order to do this. In essence, the principle of selection, much like problems found in nature, right? Now, what's fascinating about this, of course, is what are the implications for behavior analysis? Just from big data, just the big data part of this. What if you knew, given the certain characteristics of the child you're working with, where they lived, what kind of facial cream their mother used? It sounds facetious? That could be an important piece of data, right? Where they lived, the traffic patterns in their neighborhoods, the weather, the climate, the income, and so on. You could say this procedure would work better than that procedure, right? You can begin to develop and look at, based upon feedback into these genetic algorithms, what would be a much better precise procedures based upon the characteristics of the people you're working with. All right? Here's one example, feedback-informed therapy. In this, they use an analysis of patient behavior as they go through therapy. Is fed back, the notes go into the system, as well as surveys and so on that are being conducted. A whole area of data are being brought in, and they can predict patient deterioration better than therapists. In essence, therapists think the patient's doing pretty well. This comes back and says, no, they're not. I'm sorry. And this was actually developed by a therapist who had a computer science background, who's had someone attempt suicide who he thought was doing really well. And he said, how did I miss that? And he went back and he found out that these particular analysis, big data analysis of their patterns combined with his other data, were making really accurate predictions about their deterioration and what they're going to do far beyond. And now they've run clinical trials with randomized controlled studies, and they found that the algorithms are much better than therapists at predicting what's going to happen to your patient. Subsequent to this, by the way, there has been research now that just recently resulted from a Harvard group. It just came out in 2017, which showed that 76% of patients lie to the therapists about how they are doing. They claim they're doing better. They're, oh, we're doing great. Yes, I've learned, yeah, this acceptance has really turned my life around. Blah, blah. They're lying, and they admit it when you ask them. And they ask, why are they lying? And you know what the answer is? They like their therapists. They don't want to disappoint them. You know, they put in so much work with me, and they're just such nice people. I just don't want to have the heart to tell them that, you know, I'm miserable. Don't have the heart. That's the reason. And my son actually did some work on this area. I won't go into that, but it's pretty interesting to show response bias in these questionnaires that you give. You know, where how he did an analysis of psychological flexibility questionnaires, and he showed that you can attribute all the improvement to response bias and pleasing the therapist. Really, really interesting. And that's a different talk, and if you want to hear that sometime, I'll be glad to talk to you about that after. Here's an interesting one. It came out and published in Nature in 2015, I believe it was, predicting psychosis from the analysis of speech patterns of at-risk adolescents. In essence, just from getting samples of speech, and at-risk means people who have a history in their family, people have certain traumatic events and so on that we know people tend to be at risk for psychosis and so forth, or for psychotic episodes. Can you make a prediction based upon their speech patterns? Now, stop and think about this for a minute. We're not talking about the meaning of the speech. We're not talking about any relations that these words have entered into. You're just talking about the speech patterns. So what do you think the accuracy is on a system based upon these types of genetic algorithm analyses that evolved over the speech patterns? In other words, you keep analyzing the speech until you make and getting more and more accurate at your diagnosis. Go back and look at it, look for patterns, and keep adjusting the algorithm until you can make the diagnosis. What is the predictive success, do you think? Anyone want to take a guess? All right, I'll tell you. 100%. They can tell 100% 6 months prior to the episode. No symptoms. 6 months prior to the episode, they're 100% accurate at saying who's going to have an episode. 100%. Think about that. And they're not doing it by looking at, and they're looking at it by looking at the sequence of words and how they're coming out. If you stop from a verbal behavior perspective, then, you know, first thing you look at is saying, oh, what they're looking at is, there's a switch from a tactile environment to an intraverbal environment. So you're seeing that the word is occasioning the next word more often and more frequently than tactile events in the environment and so on. You're falling more into an intraverbal analysis. And all of a sudden, the analysis of verbal behavior that Skinner described actually can make a little more sense. And that nobody else who's looking at this data can make sense of it. But if you look at it from a verbal behavior analysis, you'll actually begin to see the sense and the pattern that they don't see, by the way. So this can become very, very important for behavior analysis. And it also shows us that verbal behavior, and we sometimes forget this, is a motor pattern. And it's what we call a recombinant motor pattern, meaning that you can put different components of it together in different sequences rapidly, and there's a kind of recursive quality to it, not unlike dancing. You know, people say, well, verbal behavior is what separates us from the apes. Have you ever seen an ape do the tango? No. It's recombinant motor patterns that separate us from the apes, and language just happens to be one of those. And you see, when you begin seeing changes in these patterns, you begin making certain behavioral predictions. Now, it's not saying what's causing that. It's just saying that whatever is resulting in these patterns, when you see these patterns, they're going to end up with a psychotic episode. Fascinating stuff. think of the research potential. And think of what we can contribute to that. All right? And that's big data. Artificial intelligence, which overlaps with the big data analytics, because they do AI stuff to the big data, is where you have intelligent decision-making by machines, where the machines are doing the types of things that a human making a decision might do. That's why we call it artificial intelligence. All right? Sometimes when I go out and talk to people, any type of intelligence is welcome, whether it's artificial or real. What I'm going to show you here is what they've been able to do with some of this. This is the Therapeutic Session. I don't know if any of you have seen this before. This is actually a few years old, so they're actually more advanced. The person on the right is not a person. It's an avatar. This avatar is going to respond to the actual person on the left based only upon the data that's being analyzed, considering their eye movements, their gaze, their speech patterns, the tonal qualities of the speech, what it reflects emotionally, and so forth, and what they're being used. And you can see in the different pattern areas there on the right-hand side of the screen, as this plays, I'm going to show you this video, and as it plays, you'll see the analysis, and it'll tell you what's being analyzed as it's going through. Now remember, she is responding I showed this to a therapist friend of mine who's a behavior analyst, and he said, "What's your impression?" He said, "Needs better office furniture." All right.
Hi, I'm Ellie. Thanks for coming in today. I was created to talk to people in a safe and secure environment.
This is from the University of Southern
I'm not
California,
a therapist, but I'm here to learn about people and would love to learn about you. I'll ask a few questions to get us started. And please feel free to tell me anything. Your answers are totally confidential. Are you okay with this?
Yes.
So, how are you doing today?
I'm doing well.
That's good. Where are you from originally?
I'm from Los Angeles.
Oh, I'm from LA myself. When was the last time you felt really happy?
When was the last time? I don't know. Yeah, I'm not someone who's really like, I don't have any real highs. I feel like I'm a level person. It's just happy. I guess to answer your question, probably a couple months ago.
I noticed you were hesitant on that one. Would you say you are generally a happy person?
I'm generally happy. It's just lately there are things just keeping me down.
Can you tell me more about that? When was the last time you felt really happy?
But I try to stay happy. I'd rather be happy. My kids keep me going.
What advice would you have given yourself 10 or 20 years ago?
To not believe, to not be so gullible, I've been told recently that I have a tendency to believe people too readily without them having to prove anything. And so as a result, recently I've gotten myself in a lot of trouble. And so I think that looking back, if I could have, I would tell myself to not believe, to not be so stupid, and to think and just to not be so gullible.
Is it uncomfortable for you to talk about this?
Yeah, it is. I hadn't really thought about that.
All right. Pretty amazing, right? Now remember, Sensei can't understand a word that's being said, right? They're basing the response after the emotional and gaze and auditory and speech rate patterns and so on that the individual is engaged in, and doing so quite effectively. What's fascinating about this is that better informed clinically avatars that are being developed are now being produced, and studies are being conducted as to whether or not they're effective. They're turning out to be more effective than human therapists. They're also preferred by clients more so than human therapists. One of the reasons is they don't have any confirmation bias. They don't come in with any preconceived theories, right? Using the machine learning algorithms, they keep adjusting, doing what they do until they find something that's effective. That's all they care about. They don't care about this theory or that theory or my approach or that approach. All they're doing is adjusting their patterns until they get better performance from the range of clients they get. Based upon the data, the demographics, and so on, what's coming in, they begin to adjust what they're doing. I'm on a board of trustees, the largest graduate school of psychology in the United States, the Chicago School of Professional Psychology. And one of our trustees is the head of the largest provider of psychological services to businesses for their employees in the country. 60 million employees. In 5 years, he has already given the mandate to reduce by 40% his PhD clinical staff and replace them with avatars. Not simply because it's cheaper. It's because also they're effective and people like them better. So this is what's coming. Now think about this for a minute. If this avatar was informed by the principles of behavior, by a contingency analysis, that we understand that emotions are reflecting the changes in contingencies. And so you could go back and ask contingency-related questions. You notice that they said the simple webcam that was being used took 66 different things. Well, now, in the current iPhone 10, that's a drop in the bucket. The 3D cameras and the neural engine in the iPhone is much more powerful than this. It can pick up nuances and changes that cannot be picked up by this webcam, and it's just built into your phone. You know, this thing, right? That's it. I could be talking to my therapist here. The camera, this is the iPhone 10, the camera, the 3D camera here could be picking up my face and analyzing this and feeding the same data back. Through my Apple Watch, it's getting my heart rate and other biometric data, and it's getting back data and physiological changes that no therapist has access to when they're talking to their client, right? And so now the data being fed back to a virtual therapist who is contingency analytically informed could be a massive effect. See what I mean when I say we're on the edge here? And this is just the beginning. This is 1999 in the internet world. This is just the beginning. So think about this in terms of the opportunities and the businesses, if you want to, that's good, that we're having here. All right? And let's go, where are we at here? Somehow I've lost, let's get through here. All right. Here's one. So we don't leave out our canine friends and our animal friends. This is completely automated dog training. The little robot there, the blue thing there, is connected to this dog through this harness it's wearing, which gives you the physiological feedback from the dog, but also where it is in space, where it's and how tense, relaxed his muscles are, whether his butt's high or low, and what it is. And this dog, using this system, using this feedback, this is from the University of North Carolina. I'm sorry, North Carolina State. Don't want, they're foes, so I don't want to mix it up here. Shaped this dog to sit with no human intervention. It actually shaped another organism's behavior. Think about this. It used the feedback from the system to shape this dog. And the little blue thing, by the way, it's got a thing where it dispenses the treat for the dog. The dog comes up and eats right from him. That's why he's looking at him like that, like, okay, when's the next one coming? I sat down, just like you would if you were shaping it, right? Then you'd become the same thing. So these systems, these automated systems, are such that you're actually going to be able to go out and shape in the environment the behaviors, and they're being done without human intervention. There's no human here at all involved in this shaping. It's just that guy there. A little blue guy. Pretty amazing, right? I would say if you're in the dog training business, you might want to look for another business. But actually, you might want to look at it if you're in any kind of training business, come to think of it. We have different kinds of artificial intelligence. We have what's called rule-based AI. And these are algorithms that mimic what people think people go through when they make decisions. And these are usually reflected in terms of what we call flowcharts or algorithms. And so based upon certain decision points and algorithms, the expert system or the rule-based system computes and does it much like a human would do. Oftentimes, the decision trees. This is American baseball, and you're trying to look at the outcome of a pitch. And these are that particular decision tree outcomes, and you feed this into a machine, and it can tell you the outcomes of the pitches and do all this type of stuff. And basically, these are efforts you can go through and replace umpires and so on with decision-based systems and artificial intelligence and so on. These are relatively common, these types of things, and they've been around since the 1980s earlier. These are not new things. What's new is the computing power. Again, in a typical phone, there's more computing power in your smartphone today than of a Cray supercomputer of 1987. So when these algorithms were developed, you needed those big Crays. You got it. This is where our internet browser and our internet and our high bandwidth has now allowed us to do things. Well, this is what's happening here. Machine learning is different than the rule-based systems. Machine learning means that the software learns through its interaction with the environment through reinforcement, typically. Now, there are several types of training regimens in machine learning. They're not all reinforcement learning based, but many of them are. And they actually take principles from the operant laboratory and apply them to artificial intelligence to train these systems. They lack certain things, which I'm going to mention here in a minute, but by and large, they do a pretty good job. They're finding that, guess what? Reinforcement learning actually works pretty well. And these machines do very, very complicated types of work. All right? This is, for example, a visual representation of problem-solving behavior on fraction problems done by students. And as they move through, the goal solution is get to the green area there and so forth. But they can tell you that if you get to certain nodes, you're going to end up farther away from your goal in terms of problem solving than not. And so by analyzing these and learning what the students are doing, the machine adjusts and gives different kinds of problems and different types of instruction and generates new problems that actually corrects it. So that over time the machine learns how to actually generate curriculum. And this is an actual company in Seattle called Learn. And they're developing, and they have this as a visual representation of the data. And this will be from 30,000, 40,000 students. And so they're developing software where you can basically place any curriculum in, and it will analyze the curriculum, and then through machine learning learn it, and how the student should be responding, and then begin to adjust what the student gets presented based upon their performance in the system. Think about that for a minute. They're doing this lightning speed, right? This is DARPA. This is the Department of Defense's development area where they develop all this amazing, sometimes very frightening technologies that typically have defense implications. And they have a goal, a new DARPA project, is to create computers that think like biological entities and are continually learning like humans. Such systems would be better making decisions and formulating. They believe that if they can get a system that mimics human learning and is sensitive to the consequences of its environment, that they will have a more sophisticated computer system. All right? And so they want to get it so that it can come up with unanticipated events, situations it's never seen before, and be able to figure it out. So this is one of the avatars created by DARPA, and here is a little interaction. The person is saying, "You are now God, but for only 15 minutes, what do you do?" And here's what the machine answered. Not programmed to answer. The machine was not programmed to answer this. The machine learned this through basically being raised, almost as you'd raise a child, in a reinforcing environment, shaping their behavior. Trick question, surely. You didn't include the standard genie clause. I cancel law, which means I'm only got it for 15 minutes. Then I've got lots more time to think about it. All right? Pretty smart for a computer that has not been programmed. See, this is the important part. You can program these smart responses in here and you say, oh, that's cool, you know, or draw them from a database of phrases. No. This was generated completely independently in the verbal repertoire of this system based upon reinforcement learning algorithms over a long period of time. They raised this computer as though from child to adult. Think about that. And think about the implications for our research and what it means. All right? This is another application. I like to show this because this begins to get into the area I call the creepy, all right? Which means this is an actual product you can buy today. This isn't a future effort. This comes out of a research lab. You can walk into the store and buy this product. You can order this online. $2,500, not cheap. That's $2,500. It's a lot. You know, you can throw them up, but you can buy this. What I'm going to show you here. All right. This is available in Japan.
朝ですよ。起きてください。ねえ、起きてってば。おはよう。おはよう。あ、今日雨が降るかもしれないから傘持って行って。急がないと遅刻しちゃうよ。行ってきます。行ってらっしゃい。気をつけてね。
There's texting them on their way to work now.
で誰かが待ってるっていいもんだな。さっき思ったんだ。帰ってくるとき。おやすみ。
おやすみなさい。
You get to design your own character. Pretty, as one of our famous philosophers would say, Larry David. Amazing, right? This is actually going, she's talking more about it, but I won't do it. All right. I'm trying to stop it. Yeah, there we go. The $2,500. There you go. What's fascinating about this, of course, is what's it replacing? Yeah. Yeah. It's replacing real human contact, right? And it provides you with, and by the way, she'll watch TV with you, drink tea with you. There's many things here that's not shown. She interacts in a major way with the person. And you can design her in any way you want. Now, she's a little container this big. But how long is she going to be in there? Probably not too long. As a matter of fact, I'm going to show you something in a bit that'll show you that she's going to be out of that container pretty fast. And she's going to be life-size. And you know the 3D technology that's in the current iPhone, right? Well, what would stop anyone, think about this, from taking a picture of you, doing the 3D analysis, and you become the companion? Think about that. You could be living with someone that you don't even know. Never talk to, right? Uh-oh. He wants me as a companion. That's a good choice, I would say. Very entertaining, fun guy. Could use a little more hair. But but think about that. But think about its implications from a behavior and analytic point of view, not of just the technology, but the effects this technology is going to have on social contingencies and our role in analyzing those and understanding those and helping people adjust to those. Right? Think of the change in the nature of the relation of the contingencies based upon these technologies. And what we need to be training our students to be thinking about. You know, when you stop and look at this, our students need to be prepared for this world. That's not coming tomorrow. You can buy this today. All right? All right, take a look at this person here. Except this isn't a person. You know what this is? This is a sex bot. This is an artificially intelligent companion that is full life-size. You can also buy today, only she costs $15,000. What's fascinating about her is that they are putting in some of the same technologies that you saw in Sensei, right, into her. So she's looking at you, looking at your gaze, your tone, and she has one other thing. Her body is filled with sensors, so she can respond to touch. Pressure, touch, sensitivity, how it works, and they're putting in machine learning algorithms so she learns more and more about you. And she can be updated. You can take her in and get a better one. You know, say, hey, I need a little more pizzazz out of this one. And they can just retrofit $2,000. By the way, here is a picture of the heads being made in the factories. This is the first. They have a skull. They have a skeleton-like thing, and the jaw works, and so forth. Then you can see that the head piece has been put on with the eyes, and then the face is being fitted on there. And this is a massive. They have actual mass production and production of these Adels. And the reason I bring this up is twofold. One, I think this is the industry which will drive the development of lifelike and human-like robots. Now, you don't need someone who looks like this to clean the floor or to be sensitive to you in many ways. But if you're going to have an intimate relationship that mimics what you would have with a human, You're going to want more and more increasingly real environments. And much like the adult entertainment industry actually drove the development of the VHS cassette tape. Look back in the history, the innovations, right? That's what drove the industry. 35% of all VHS tapes were sold by the adult industry. This is what's going to be driving this next level of intimate and connected androids, is probably this industry. That's why I brought it up here. It's not just because it's kind of prurient. By the way, they have males too, so this isn't just females. But they sell at a rate of only 1 to 10. There's 10 female dolls versus 1 male doll that is sold. But they will provide both, and all it takes is $15,000. And I forgot the name of the company. Something Dolls, Real Dolls or something it's called. And they're developing this technology all the time. And so let's stop and think about it when it's no longer a sex bot, but a teach bot. Right? Hugging your child at school. Totally devoid of any prejudice. Right? Or confirmation bias. And learning to interact with the child based upon what's most effective through time. Connected to sensors that are connected to your child, that are feeding back your child's physiological state and brainwaves. And this teacher now is assimilating this at rates that you, as a human, could never do. And adjusting. They know that this child is becoming confused before the child knows they're confused. And adjust their behavior to respond to them. When you talk about Skinner's teaching machine, these are the teaching machines. All right? Think about that. And think about the opportunity we have to help design and develop these, because they're coming whether we want them or not. They're going to be here. All right? Here you go. Just recently happened. In just 4 hours, Google's artificial intelligence that they created mastered all the chess knowledge in history. That means of all the ways and variants of playing chess and so on, and developing it. And then it played the world's best chess program and beat it. All right? It beat the world's, and here's what made this amazing. It only played itself. It never played a human, and it never played another program. It played itself. In other words, they taught him the rules of chess, and that just simply means how the pieces move and what the objectives are, to get a checkmate or to get a draw, and what the pieces move, and let it play itself. It would move, then it would move. It would move and move, and analyze the counter moves, and in 4 hours, it learned all the knowledge about chess just for playing itself. No knowledge was put in the system. No past experience of any great grandmaster was put in the system. It played no other system. It played itself. Now, what's important about this? This is a level of self-teaching that humans cannot do. This now is a slightly different species. This is not artificial intelligence and reinforcement learning based upon how you interact with the environment, but how you interact with yourself. And it's done so fast because, of course, the computational power, right? You're not playing like a regular time of chess game. This chess game takes a fraction of milliseconds to play. These are computations going on at lightning speed. And with the technologies and computing power we have today, what is it going to be like with the technologies and computing power in 10 years? These things are going to be learning at astronomical rates anything that you put in front of them. Apple now has and this is their company based out of Seattle, has large neural network systems that learn complex tasks and then immediately teach it to small neural networks that go in your phone. So the big ones go through all of this, and with supercomputer level of speed and ability, And then once they've refined it and got it out, they teach the siblings. It's like a teacher in a classroom. And they teach the small ones that go on your phone. Now, they can do the same thing as the big one, but the big one it took to figure it out. But then now the little ones can do it and can continually learn. This stuff is happening, folks. So what does this mean? Well, the first thing that's happened is AI-assisted training. This is from a emergency situation of a child who's being upset and what you should do. And this is advice given to parents by an AI agent working with autistic parents of autistic children. And they are giving, based upon the feedback of the interactions, and all you're doing is pushing on either the X or the check mark. Based upon what you do in relation to what the child does, it analyzes what you're doing in relation to your child and shapes you to do the best thing possible in the given situation. This product is in beta today. I'm working with this group. Actually, I'm an advisor to it, to this group here. So this is actually happening so that you can have real-time AI-assisted interactions for parents with their autistic children. One of the reasons I'm interested in this is that it costs so much for treatment. But if we can automate it and get much of it out and have it adjusted through machine learning and learning what's the best all the time, well, we can get fairly effective treatment out pretty fast. So it's not even based on, of course, the program has to go through the BCBA. No, here's another one. This is another company. And this is an individual. The child is off to the right there. You can see the hand on the bag. And in the ear, he's got an earpiece. And based upon the child's, what the child does, the person hits certain buttons on the machine, and then the AI-assisted coach tells them what to do next. And so this person is being guided in their interaction with the child through an AI assistant. And so you don't have to have super well-trained people to have the best training. And by the way, again, and the results are being fed back. And based upon these results and the demographics of the child, remember the big data analytics and so on? But the big data analytics, combined with the feedback of the machine learning, it's getting better and better. It's becoming a better assistant, better supervisor, using data that humans would take weeks to even begin to analyze. It's done instantly. All right? This, by the way, is a product you can buy today. This isn't my plan. Now, remember the features here we had here. The facial recognition and what's being done. And this is a laboratory at the University of Southern California. But these are coming. These are augmented reality glasses that are going to be looking at the environment and analyzing using these 3D depth cameras. And by the way, this is my hotel room this morning. And if you can look what's walking across my desk there, anyone see the Tyrannosaurus? And there's some up there flying around. There's pterodactyls. I have an AR application, an augmented reality application on my iPad that I can put here, and we could watch dinosaurs come walking down this hallway here and pterodactyls flying through the room. And I can hold it up here and see it. That means that when I'm looking at a child or looking at anything else, I could have a model right here next to me. I could have data being played out. I could have anything that I wanted to be part of the actual reality. That's why they call it augmented reality. It's not virtual reality. You're not enmeshed in an artificial world. You're taking artificial things and imposing them on the real world. That's what augmented reality. These are what these glasses will allow you to do. Now, if we think about that, and then we look at the Apple, for example, 3D technology that they have in the phone, that they make available to developers now, that is then linked directly to what's called the core ML, that means core machine learning, which allows you to develop machine learning algorithms without having to code it. You just have to tell it what you want it to do and analyze, and it'll do it for you. All right? These are tools that are being developed. All right? This one, and by the way, it works in total dark. It can analyze your face. It can look at it uses infrared. There's no light required. Right? So you're looking at that, and think of it now. You're working with a child. It's looking at that child. It's using all the things. It can sense their eye gaze, their movements, their fed. You got certain sensors on there that's being fed back. You're getting a readout here of what to do and how to do it, and a model being placed next to you. Yale University is doing this now to train surgeons remotely. All right? And actually, a woman who has behavior analytic training is running that program. All right? The daughter of a fairly well-known, Roger Ray's daughter, is doing that program at Yale. So what we're seeing here is a tremendous opportunity. It's also a challenge because, quite frankly, much of what we're training our students to do are going to be done by these systems. And here is the part that's fascinating. It's going to be done better. These systems are going to be better than the people because they're very sensitive to their environment. They're very sensitive to the contingencies, and they're very sensitive to contingencies that only the machines can come in contact with, that we can't. So we're going to have to learn to adapt to this new environment and build our repertoires and our programs to address these. This could be probably not looking quite like this, probably a little better, more like, you know, the Sexpot lady, working with the children, right? This one, by the way, is available today as well. That one there, working with the kids. Systems out of Columbia University, in systems out of Florida. There is a virtual reality system that I'm advising with that is applying some of these technologies in virtual reality where the child actually puts the virtual reality goggles on. So let's say you want to teach a child, a developmental child, how to cross the street. With the virtual reality, you can have all kinds of streets, all kinds of conditions, daytime, nighttime, afternoon, traffic, no traffic, country, city, everywhere, right? Just right here. You can vary, you can look at the critical features and the varying features and mix them up in a juxtaposition of rational sets and train much more rapidly across the range right there. And this product is being produced and is in beta right now. All right? So the next question is, how will behavior analysis affect AI? We have an opportunity here to actually join some of these teams, to actually help. And this is what I'm spending my time doing now, is I'm trying to work with some of these companies and some of these areas to help them inform them of how contingency analysis and what we've learned can have an effect on what they're doing, and help them develop better algorithms and develop better machine learning technologies. So that, and the reason I'm interested in the animal training is that there are two major types of animal training in the world. There are more than two, but two major types. Reinforcement-based, positive reinforcement-based, like clicker training and so on, and what's called compulsion training, where you're the alpha and you got to force the dog and you use compulsion training. I am working very diligently to promote reinforcement training so that for pets, so that when the robots take over and we become their pets, they use reinforcement-based training on us and not compulsion training. So there is this is a vested interest here in this effort. You know, if I'm going to be a pet, I want to be treated, you know, with a clicker and some food, not get over here and do this, push your head down into the food, you know, and slap me around. All right. Here's an interesting little project here of how behavior analysis can affect. This is a typical neural network. Here you see the input units, the A, B, and C. There are hidden units, which then take and adjust weights of the incoming based upon the results it's having, and it's fed back. And those weights then adjust the output units. So here is a musical chords, 1 and 2, and there is if you hear musical chord 1, you press button 1, and if you hear 2, you press 2, right? The top and the lines are talked about the weighting they have, meaning that they're given certain likelihoods of being activated, the hidden units and so on. The top one is through trial and error procedure, same neural network. The bottom one is when you use a fading procedure. The procedures used to train the networks result in different network configurations and outcomes, and you can make different predictions based upon the behavioral training procedures used. This is almost never used in training these systems. There could be a tremendous research effort alone in behavior analysis on what are the optimal, and when do you want number one, and when do you want number two, right? In other words, the middle units are not stimulated at all in the fading procedure, right? But in the trial and error procedure, they are. And suggests that disruption to the systems, facing new environments, a whole range of other variables will affect these systems differently based upon not their internal structure, but their training program. It'll be the training programs that will affect the outcome as much as the configuration and method of calculating in the network. Think about that for a minute. The contingent history of these systems is what is going to govern what they do. Not how they're put together in terms of how the internal units connect together. Again, the story isn't the internal story. Isn't that interesting? It is not the internal story that is the real interesting one here. It's their relation to their environment. Look at how relevant that is for behavior analysts. Or more precisely, contingency analysts, because that's where the real story is in the contingencies. Pretty exciting, huh? All right, that's it. Thank you.